Okay, so I forgot to turn on the video to begin with, so we're starting now. All right, so just to recap what we just did here, everything is the same from previous units, where we just have to figure out our A value, B value, C, and D, right? So this should be familiar. So you can see that we have a vertical stretch of 5 for our A value, horizontal stretch of 2, right? Because it's going to be 1 over 2, so 2. Vertical translation 3 up from this one, and then a horizontal translation of pi over 2 to the left. All right. Hopefully you guys are caught up with us now, so we'll keep going here. All right, so let's go. I'm just labeling this now. It'll be -1, -2, 3, -4. All right, and we're gonna go up by. We're gonna go up every 2 of them. We're gonna call pi. So pi, 2 pi. I'm gonna go a little tick too. Go 3 pi, 4 pi. 5 pi, 6 pi, and 8 pi. All right. So now what we're going to do first, we are just going to graph just the base function of y is equal to sine x, or sine theta. In this case, right, theta is going to be like on our x. Right, so we're going to start at 0, because sine starts at 0, and pi over 2 would be at 1, and then it'd be at pi, and you can kind of see it would follow that pattern, right, all the way around. So let's just kind of draw that. All right, so that would be our base function, right? All right, so now let's make our mapping notation. So let's go x comma y is going to turn into what? Well, this is where we're just going to use these, right? So we're going to say our x value is going to have a horizontal stretch of 2. So it's going to be 2 times x. And then it's going to have a horizontal translation of pi over 2 to the left. So would that be minus or plus pi over 2? It is minus. It's actually the way it's written. It's not backwards here, right? It's just backwards in the equation. So minus pi over 2. Oh, not a bracket, sorry. Okay, and then our y values are going to have a vertical stretch of 5, so that's going to be 5y. And then 5y, and then a vertical translation of 3 up, right? So that's going to be plus 3. Okay, so this is kind of like as soon as you get this figured out, you're pretty good to go, because now any of these points that were on our original one, if you plug like this point into, here, the x and the y, that'll be where our new point is. Yeah, so let's do an easy one first. Let's figure out where the point 0, 0 went. So if I go down, so the point 0, 0, so I could go, okay, 0, comma 0. Where did that go? So that'd be 2 times 0 minus pi over 2, comma 5 times 0 plus 3. So this point would now be at negative pi over 2, comma 3. Okay, so this point right here, right, make that green, is now going to be at negative pi over 2. This kind of sucks because it's in the way here, but negative pi over 2 is right here, right? It's one line over, because negative pi would be right there. So negative pi over 2 is right there, and then it's going to be up at 3. So it's going to start right there. So that's going to be like the start of our, like that's where this point went. It's up there now. And we really, when we're doing this, you really, like, you're going to find that you got to just throw, like, 3 points in, and then you're going to get the gist of it. And then you just kind of follow the pattern all the way along. So let's just throw another point in. So let's do the point, like, where did this point go? Like pi over 2. So pi over 2, so this point was at pi over 2, sorry, comma 1, right? So using our mapping notation, let's say, okay, where did pi over 2 comma 1 go? Okay, so that went, so if I use my mapping notation from up there, right? That went to 2 times pi over 2 minus pi over 2. Okay, and then the y values would be 5 times 1 plus 3. And then we just got to clean this up a bit. 2 pi, like the 2's cancel there, so I've got pi minus pi over 2. Maybe I'll just continue on with this one. This would be like 2 pi over 2 minus 1 pi over 2, so this ends up being negative pi over, sorry, this ends up being pi over 2. Not negative, just pi over 2. So pi over 2, right? And then this ended up being 8. Okay, so we get pi over 2 comma 8. So that's where our next point is going to be, right? So pi over 2 comma 8. So I can go back here and say, okay, at pi over 2, so this one, I'm at 8. Okay. Can you guys kind of see, like, you can probably almost get like a vision of where this thing is going. This was my midline to begin with. This is still going to be my midline here now, right? All the way across there. And I've even got a start to this where if I go up here, that's going to be my peak. You could probably fill in the rest just knowing about like the symmetries of these things, right? So it's going to probably cross, I'm guessing, right here. Right, you can probably see that, eh? And then the next one would be, yeah, you could go, oh, sorry, not that one. That should have been, sorry with this line the way it is. 2 over, sorry, that should have been there. Right there, not that one. Okay, so they go up like this, and then it would come, down like that. And then do we want to, let's figure out where this point went. And then that would just kind of probably fill out our picture a bit better, right? Like where the low point on the original went. Okay, so that would have been, what would that be, Gary? Sorry, not being mean. 3 pi over 2. Okay, so 3 pi over 2. Okay, so where did that one go? So 3 pi over 2 and negative 1. So again, I'm just going to use my mapping notation. So where did the point 3 pi over 2 comma negative 1 go? So again, we're just going to throw it into our original, or our mapping notation that we figured out, right? So that's going to go to 2 times 3 pi over 2 minus pi over 2. Sorry, that should be minus, it looks funny. And then the y one would have been 5 times negative 1 plus 3. Okay, those 2's would cancel. Okay, so we've got 3 pi minus pi over 2. And then this is negative 5 plus 3, so that would be negative 2. Okay, so I just need to figure that one out. You guys could put it in your calculator too at that point, right, if you wanted to. Just go 3 minus 1 over 2. But we'll do it. So we're going to call this over 2, right? So times 2 on the top and bottom. So this is 6 pi over 2 minus pi over 2. So this would be, yeah, 6 minus, so 5 pi over 2 5 pi over 2, comma, negative 2. Okay, so 5 pi over 2. So 4 pi over 2 would be, so 4 over 2 would be 2 pi, right? So we're just at like the next one, around. So that's going to be like at this point, right? Okay, yeah, which makes sense, right? And that's going to be down, our y value would be down at negative 2, we said. So negative 2. So negative 2. And this is all kind of making sense, right? Well, hopefully. Okay. Does that kind of make sense, guys? Then you just follow that pattern all the way across. You wouldn't have to find every one once you found a few to get the gist of it. Everybody good? Okay. All right. So go on to the next one. All right. So now it's doing the opposite. It gives you an equation and it wants us to write the equation for it. All right. So what this requires, we can write this. I'll show you in the end how this works, but we can write these as either a sine function or a cos function. The only thing that's going to depend on the sine function, the cos function, is whether this graph, like, moves this way or whether it moves that way or what it's doing. But you can talk about any of these as being a cos function or a sine function. But I'll show you when we get to that. It'll make a bit more sense then. So let's just say sine function for now. And we just need to figure out what the a value is, what the b value, the c, and the d is. And then we're just going to like plug those into our equation when we're done, right? So let's figure out the a value. So the a value, right, the amplitude, your a value is going to be your max minus your min divided by 2, right? That's really going to tell you when you do that, there was a midline there, that's telling you your peak, right? That's your a value, is how high this thing is going to be. So max, so this point minus your bottom point divided by 2. So if you do that, we're going to have our max is negative 0.5. So negative 0.5 minus negative 1.5. So minus a negative, I'm just going to call that plus 1.5 divided by 2. So we end up with a is equal to negative 0.5. Okay? You guys agree with that? What's that? Oh, you know what? Oh, yes. I made a negative. You could have made a positive. All the negative's doing is flipping the thing upside down. Right? You can make it positive. I'll show you how they all end up, like how it'll end up either way. It'll make a bit more sense. Just say like negative or positive for now. We can kind of change that thing depending on whether we want to talk about it as being flipped or not. Okay? Yeah, so I'll just leave that for now. Maybe put a box around all the things that we want to throw in for later, because that's going to be important.
Isn't 0.5 plus 1.5 just
1. Yeah. And then divided by 2. Oh, yeah, sorry, divided by 2. Sorry. Okay, so we got that one. And now next one here.
But couldn't we have just taken?
You could, yeah, just do that, yeah.
Rather than doing that, because that's got me confused.
This just is the equation that also works, but yeah, if you can intuitively do it, do that. It's going to be, yeah.
You could just do that, do the y value at the top minus your center value.
Yeah, if you know your center value, then yeah. Do that. Yeah. Okay, so our D value now. So our D value is going to be our midline, right? And we got to figure out where that is. So our midline here is really going to be the average between our top point and our bottom point. And maybe you can see that from the graph when you're looking at it sometimes. Maybe you can't. So let's put it in where it's your max value. plus your min value divided by 2, right? We're just finding the average between those numbers to find our midline, or our D value. So our D value is going to be negative 0.5 plus negative 1.5 divided by 2. So our D value ends up being negative 1. Okay, so we're getting there. We got A, got that one, and we got our D value. We just got to work on B and C now. Okay, so our B value, well, any ideas? How can we find our B value?
Well, we can go from where 0 is to the next point.
Our B value really is our our horizontal stretch factor, right? That relates to the period. Does that make sense? That relates to the period. Do you guys remember that formula for period? Yeah. So, so B is equal to 2 pi over P, right? So if we have our period, just from looking at the graph, we can probably figure out what our period is. Then we can just go 2 pi divided by that to figure out our B value. So let's look at this and see if we can figure that out. So the numbers that they gave us weren't great, right? But what if, so these are my X values right there and there. So what if I go 2.62 minus 1.57, right? That would give me the distance for half of it, right? Because that's like half of a period. And then multiply that by 2 to get the full period. That all make sense? Okay. All right, so let's do that. So I'm going to go, hopefully, I'm running out of room here, but I'm going to go, okay, the period is going to be equal to 2.62, right, this number, minus 1.57, and then I'm just going to multiply that by 2 to get the whole period. So period would be equal to, and it doesn't end up being a nice number, it's 2.1. So it doesn't end up like, yeah, it's close to 2 pi over 3, but we'll just call it 2.1, just we'll deal with the decimals instead. Okay, so that's period. So if I want to find my B value, B is going to be 2 pi over, or period, right? So over 2.1. So that ends up being really close to 3. So we're just going to call it 3. All right. So we're pretty much there. We've got 3 of the 4 things that we need to make turn into an equation, right? Now, let's say I just want to show you the different equations that we could put this in now. So y is equal to, and we're going to assume, like I said, that the thing has been flipped upside down, because normally a sine function, right, would go up, would start going up and then down from there, right? So we're just going to assume that this thing got flipped upside down right off the bat. It got reflected there, right? That's why I called this A value negative 0.5 to begin with. So we'll write it out like that. So it's going to be negative 0.5 times sine of 3 times x. And now this is the one that's going to change depending on whether you're talking about a sine graph or a cosine graph. Is like, no, because this actually is our B value. The 3 we found, it's not, that wasn't the stretch factor, that's actually the B value. Yeah. So it's 3. And now we need to figure out what we do for our C now, right? That's going to depend on like what we're saying happened, right? So we're saying that this thing just got flipped upside down like this, right? So how much did it move to the right or to the left? We're saying it didn't in this case, right? It just flipped upside down. So our C value in this case would be 0. It didn't move, right? It didn't move that way or that way. It stayed right where it was. Yeah, so that would just be 3x, right? And then what's our last number? That was our D value, right? So minus 1. Okay, so there, that is our equation, right? So that would work. I just want to show you the different ways that this could be written though. So we could also talk about this thing as being y is equal to, and now let's say that it was just 0.5, right? 0.5 and not negative. Well, if that's the case, here, let me clean this up a bit. If that's the case, then we're now saying that this thing shifted, right? It from like it was here, and it shifted that way, right? It shifted that far that way. It shifted whatever that was. Yeah. So that's going to be. Yeah. What is that one again? Oh, yeah. So we're going to have to figure that one out. So this point here, would you guys be able to figure that point out right there? Like what that was, what the x value was at that point?
The y value would be -1.
Yeah. Knowing that this thing is symmetric, right? So if this is 1.57, and this would be halfway in between, it would be 1.57 divided by 2. I know it doesn't quite look like it the way it's drawn there, but that would be symmetric, right? Going down that way. It should be the same. Like if that's a dotted line going that way. You guys are looking at me funny. Does that not make sense?
But isn't 1.57 just to the right of that? Is it at the top?
1.57 is the peak, right? That was the beginning. Right, if I drew a midline across this thing, like right here, 1.57 was to there, was the whole thing. So this to there should be half. It looks like it's not doing very well, but yeah, that should be half.
Oh, okay. Yeah, makes sense.
That does make sense. Or it's not half. I think just the scale's funny, or like I think the picture's been stretched or something, like when we're looking at it. But it would be half. It's got to be symmetric. You guys trust me on that one now? Okay, so we'll call that point. If you divide that by 2, that point's going to be 0.785, comma -1. Okay, so this thing has been shifted that way, right? So now we're going to write out this. So this will be 0.5 times sine of 3. And now here's what changes, right? It's going to be x, and then x what? Yeah, x minus 0.785. And then the end is still going to be -1 because that's still our midline. Okay, but then we could also talk about it in a different way. It could also be considered a cos graph, right? So y is equal to, and let's say 0.5, but now we'll say cos. So if this was a cos graph, this was a cos graph, here we go, black. Okay, cos starts at 1, right? So we can kind of assume that this thing moved that way, right? From 1 over to that point there. So how far is it going to shift to the right? 1.57 to the right. Yeah, so everything's going to be really similar here now, but it's going to be 3, well, yeah, whatever, x minus, what did I say that was? 1.57? 1.57. And then -1. Yeah, so all 3 of these work. That one, that one, that one. We could have also talked about what it would have looked like if this was a negative, right? Then that would have been the cos flipped upside down, and then it would have started from here, right? And then how far did it go that way? Well, it would have went 2.6 to the right. Or you could have talked about it as going that way. So that would have been however far this was, so you'd say plus that number. So this is kind of the hard part about these ones, is figuring out that C value. So really, if we look back on what we did, right, we found A, we found D, we found B, just pretty straightforward, I think. And then you do what you have to do to figure out what your C value would be, depending on how you shifted it. All right. Okay, gets a little easier for the last one. Now we're just going to throw the numbers on. So write an equation for each cosine function in this form. So give its characteristics. All right. So given its characteristics. So it has an amplitude of 2, a period of pi, a phase shift. Phase shift means the horizontal translation. Pi over 3 to the left, and a vertical displacement of 1 unit down. Okay. So the only thing we don't really have here is a b value, but period's close, right? So b is equal to 2 pi over period. So your b value is going to be 2 pi over pi, right? B is equal to 2. And now we can just write it in, right? So let's just fill these in now. So y is equal to, our a value is 2, cos, our b value was 2, and then x, and it was a phase shift of pi over 3 to the left. So what's this going to be? Plus, yeah, plus pi over 3. And then 1 unit down, so minus 1. That's it. Okay, next one. Amplitude of 1 over 4. Period of, oh, it's in degrees this time, so 540 degrees. Phase shift of 60 degrees to the right. Vertical displacement of 2 units up. Okay, so again, we just don't have the b value yet, so I'm going to say b is equal to, and since it gave me the number in degrees, I'm going to say 360 over the period. Okay, so then b is equal to 360 over 540. Okay, and that would simplify to 2 over 3. Okay, sorry about that. I had to run and do something. Okay, so let's finish this. So our b value was 2 over 3, we said. So now we just got to kind of fill it all in, right, with cos. So it's going to be y is equal to our a value, let's say it was 1 over 4. Okay, our then cos. And then our b value, we just said was 2 over 3. And then times x. And now it says a phase shift of 60 degrees to the right. So the opposite of that, so it's going to be minus 60, you can say degrees if you want to do there. Okay, and then finally has a vertical displacement of 2 units up, so just plus 2. Okay, that's it. Okay, so hopefully that made sense. Did I push record? Yeah, I did. Okay, that's the end of the video.